Hello there, my super exceptional, wonderful chemistry students. Video number 4, Arrhenius acid theory. Yes, that's how I say that, Arrhenius. And here's the deal. This is the nuts and bolts of the whole unit. This is why acid bases work. Arrhenius theory covers almost every acid and base. The next notes will be basically the exceptions or these alternative theories that came up with a new way of thinking to figure out which ones these don't cover. There's very few exceptions to Arrhenius, and we'll probably highlight them along the way, but this is the video that we need to pay attention to the most. This is where the rubber hits the road, so to speak. Yeah, so let's just look at the atomic level, what's going on with the dissociation of an acid and base, and why an acid is an acid and a base is a base. So Arrhenius acid, once I'm in aqueous solution, it yields these hydronium ions or H plus ions, okay, as the only positive ion. Okay, so let's look at this example and we'll understand a little bit. If I have HCl, I go to H plus ion and Cl minus ion. It's that H plus that we call hydronium. And we're actually going to see that hydronium is really H3 plus, and we'll get into that in a second too. And you'll see why they're synonymous. They're actually equal. Here, though, I have, in sulfuric acid, I have two H's, so I get H plus, and then this sulfate ion, and now I have 2 moles, right, of H pluses as opposed to the 1 mole here. So 2 moles is stronger. So that's how we are going to determine relative concentration. In acids and bases, I do want you to understand, strong does not mean it will burn you. Strong means specifically that I dissociate 100%. So what that means is every molecule of H2SO4 will completely dissociate into this. If I do that, then I get as many of these H pluses in solution as I could possibly get. Okay? A weak acid will dissociate some of the way. So I get some of the H pluses that I would get as opposed to the maximum amount. So when I say a strong acid, it just doesn't mean that that's going to burn you the most. Well, it might, because it's making more of these H pluses in solution, you see? But that strong acid in this case really just means it dissociates 100%. And it makes the math a little bit easier on some of the higher end math we could do with this stuff. All right, general rule for acids. Hydrogen is the first ion. We see H plus first. Okay, general rule. There are exceptions, and here are some of the exceptions. Some of these very things are going to lead to us making this alternative theory. H2O, CH4, especially H2O water, H is first, not an acid. H4, H is not first. Glucose, H is in the middle. Hydrogen peroxide, H is first, but it's a peroxide special because it has an O2 ending. Very, very specific. And then NH3, ammonia, is actually a base, and we're going to see that later, a little bit later, that that's the exception to the base rule of OH. Okay? So, the hydronium ion, as it exists, this is what happens. I have a hydrogen atom. It's got 1 proton and 1 electron. We learned that a long time ago. If my electron leaves and goes over here, I am left with an H plus, or a proton, we call that. That's all I have is a proton. And now we're going to get into why we call it hydronium. This positive hydrogen ion essentially is a proton, and in water, this H plus ion is naturally attracted to unshared electrons. Okay, so this comes up every year. This becomes the hydronium ion H3O. So if I have water with my H with no electrons, what happens is this H still wants 2 electrons, and look, here's 2 of them right there, and it's going to go and hook on. But notice, in this particular example, on this side, the H has an X and a dot, and this H has an X and a dot, because remember that the X is the electron that hydrogen brought with it when it bonded. But here, where this hydronium ion is going to go, notice that there's no X. And here's a good, here it is. There's no X. That hydrogen did not bring an electron with it. This is a special kind of a bond. This is the piece that comes up every year. It's going to be on there somewhere. It's called a coordinate covalent bond. And it's special because it's between two nonmetals, but they're not sharing electrons. Hydrogen didn't have any to give, so that hydrogen ion did not have any to give. So we say that it's a coordinate covalent bond. Okay. According to Arrhenius theory, this is what makes the hydronium ion, is these hydrogen ions. So we say that these are synonymous. If I have H plus in solution, I must have H3O in solution. If I have H3O in solution, I must have H plus in solution, because that H is going to keep popping off the water. And it's going to be like an equilibrium that we learned last unit. Then I'm going to have H3Os and H's, and they're just going to be popping around. But if I have H3O plus in solution, that will give me this H in solution at some point when the H comes off. Different types of Arrhenius acids. Monoprotic means one hydrogen. It ionizes in one step, which is HCl. HCl, because it's got one H, goes to, why did that happen? I didn't like that happened. I apologize. H plus Cl minus. Moving right along. A diprotic, di is two H's, two steps. I get H plus with HSO4, and then the HSO4 becomes H plus with an SO4 minus 2 ion, and now I end up with 2 H pluses in solution. There are some that have 3. We call them triprotic. 3 steps, if you will. H3PO4 goes to H plus with H2PO4 minus, and then another H plus comes off, and I'm left with HPO4 minus 2. And then another H comes off, and now I'm left with no H, sorry. Erase it. PO4 minus 2 ion in solution, and now I've made 1, 2, 3 H pluses. So 1 mole of a monoprotic will produce 1 mole of hydrogen ions. 1 mole of a triprotic acid will produce 3 moles of hydrogen ions. Therefore, the acidity is going to go up way faster. We're going to get into the pH in a video or two and how we calculate that. Arrhenius base. It's going to produce an OH minus in solution, or these hydroxides, as the only negative ion when it dissolves into water. An example, ammonium hydroxide and calcium hydroxide. The general rule for bases contains 1 OH at the end. There's one exception, which is on our list, which is ammonia. And I'm going to take the time right now to show you how ammonia works and how it's considered a base, okay? If I take NH, come on. If I take NH3 and I put it into water, okay, NH3 can form that ammonium ion. So if I take an H off of here and put it over here, this becomes N. Oh, I said N and I wrote an H. Mr. Milks, you have drank too much coffee today, Mr. Milks. NH4 plus ion. This is a ammonium ion. And then I'm left with OH minus, because I lost an H on my water. And I just turned it around. HOOH, same thing, right? Look at that. I just produced OH. And this produces NaOH. Calcium hydroxide produces CaOH. Okay. The hydronium, or the ammonium ion, ammonia, produces the ammonium ion and these OHs. So this is why ammonia is also a base, and part of the reason why we're going to have to figure out what's going on next video. We need another theory to cover that. Monohydroxy bases produce one OH. This goes to K plus, one OH minus. Dihydroxy base produces two, so I have Ca plus OH minus 2. Front trihydroxy base, Al, 3 OH minuses. Boom, follows the same step as before. So, not all compounds that contain OHs, for example, alcohols, those organic acids, which is those COOs, are not bases. So here they are. HOH is another way to write water. If I wrote it like this, you can see that it ends in OH. Well, we all know that water is not a base. It's water. Methanol, this is an alcohol. We will study this in organic. It's because of the C that the OHs are hooked to. When any number of these C's are in order and I end with an OH, not a base. It is an alcohol. And this is on the acids thing, the acids chart in the periodic table. It ends in COOH, or we call it COO. This is an organic acid, actually, and not a base, exception to the rule. So, we just covered Arrhenius acid and base theory. I tried to make as few mistakes as possible, but I did get a little tongue-tied in that one. Sorry about that. I hope that it makes very good sense that if I make H plus ions in solution, which is synonymous with H3Os, that makes me an acid. I make these H pluses. And bases are going to make these OHs. You have no practice packet yet. Quizzes are coming after the next video. See you guys in class tomorrow.